Welcome to Brad Kyle's Brad's Motorworks podcast, where we'll be talking about some things about BMW, some things of cars in general, and some things about car repair. I hope you find it educational, enlightening, and I hope it increases your understanding of your car. And maybe along the way we'll have some fun too. Thank you for listening, and here we go. Episode number 87, CAN bus systems. Say what? This one's going to be somewhat quick, but hopefully it's very informative for you. I actually ran, in all my years of working on cars and studying technology and all the rest of it, certainly I'm well aware of what CAN bus systems are in the network, but I recently watched a webinar that was talking about CAN bus systems, and there was a few bits and pieces of information in there that could be considered maybe trivial, or trivia, I should say, but it was like, wow, this is really good stuff. So, I thought, I'm going to put together an episode on CAN bus systems. So, here we are. CAN, what is that? It stands for Controller Area Network. And what it basically means is a way of wiring a car to where you can send multiple bits of information as a code in packets over the same wires and have multiple sensors feeding into multiple control modules without having to wire them individually, which is what used to have to happen. Okay. For many years, all the wiring in a car was all what's called point-to-point. So in other words, if you had some kind of a device or a sensor, it was wired, whether it be 1, 2, 3 wires, whatever it was, it was wired directly to whatever device or thing that it was trying to control, if that's what it was, or a matter of information or voltage input or whatever. And this all became more of an issue as in the 80s, when we started going to actual computers in cars and modules, and especially when modules were now sharing information from one sensor. Now you had to have even more wiring. Okay, so it definitely became a bit of an issue, and this is where some of the little bits of information I ran across here recently became, even I was kind of going like, wow, that's I thought it was pretty interesting. So, in any case, in the 80s, vehicle manufacturers had to solve the problem of having environmental sensors and feedback circuits wired to each module in the vehicle. An example of this was the 1986 through 1988 Cadillac Eldorado, Oldsmobile Toronado, and Buick Riviera e-body vehicles, which were reported to have, are you ready for this, folks? Over 65 miles of wiring on board to run only 6 or 7 main modules. This had to change as customer options, convenience, and new technologies started flooding vehicle platforms. While some of the original communication platforms like UART Class 2 and other early single-wire bidirectional communication protocols provided some relief to engineers in reducing the harness size, the invention, testing, and success of CAN has opened the floodgates to development. I really thought that was crazy. 65 miles of wiring in a car that generally is not even 20 feet long from front to back. But again, when you're talking about having to run potentially wiring to all over the car for, to just share information from one sensor to maybe multiple modules. So the industry's need for CAN communications. Vehicle wire harnesses are built one at a time and make up over 50% of the labor costs of the vehicle's overall build cost. That was amazing to me. I did not know that. So I'm just sharing that with you. It amazed me. Also, wire harnesses are the third highest cost component of the vehicle after powertrain and chassis. The wire harness is the third heaviest component after the engine and chassis. CAN and other data sharing protocols allowed manufacturers to reduce the number of wires in the harness, thereby reducing the cost of materials and labor in the build, but also OEMs made large gains in weight, fuel economy, and emissions performance areas. like I say, that was to me, that's eye opening. Okay, and yes, CAN's been around for quite some time, but this information is still going out there. So. CAN development. Engineers discovered that sharing sensor data with multiple modules had two primary benefits. By sharing data, the number of sensors, computers, and wiring could be reduced, a big plus for fuel economy and cost of vehicle build. Because multiple modules could share data from one sensor, the response time was far superior, as was the processing time. This was an important factor in powertrain controls, and as the onset of ABS and ABS and airbags required faster speeds. Again, big plus. Okay. CAN bus, Communication Protocol Development. In 1983, Robert Bosch, which is a huge German manufacturing company, began work on engineering a faster, more reliable communications network for automobiles that was named CAN bus, which again means Controller Area Network. This, as GM and others were developing single-wire communication lines called UART, which stands for Universal Asynchronous Receive Transmit. Excuse me. These systems evolved rapidly as customer demand for more options, comfort, and entertainment systems required more modules in the vehicle. The single-wire UART system, while reliable, could only handle small amounts of message traffic, and response times from non-priority modules was not sufficient, so Bosch went to work on the problem. Again, just some amazing stuff out there, and nowadays we have, multiple bus systems, so, it's become just that much more prevalent, so protocol development. In 1986, Robert Bosch introduced CAN at the SAE Congress in Detroit. Later that year, the BMW 850 was the first CAN bus-equipped production car. I remember when those came out. 1987, Intel and Philips delivered the first CAN controller chips to OEMs. The first multiple model OEM production runs were on the 1992 Mercedes-Benz cars. CAN was standardized by the automotive industry in 1993 and began to show up in production vehicles regularly by 1995. As of 2008, all vehicles are required to use CAN as the communication system. This is required, not optional, on behalf of OEMs. Okay, so if you haven't figured it out already, folks, there's a huge amount of information that's flying around your car all the time. Okay. CAN layers. The physical layer, or what's called node. This is the circuitry that decodes the microcontroller's logic level signals into bus protocol voltage and current signals, outputs, and also decodes bus level signals and converts them to microcontroller TTL logic level signals. In other words, CAN controller and transceiver in the node. Application layer. This layer is the interface between the HID, or Human Interface Device, and the MCU, or Microcontroller Unit. This could be a switch, touchscreen, mouse, or other device. It includes data link layer functions. Okay, so again, that's the Human Interface Device. So whether you're operating, a switch or some kind of like a joystick thing with iDrive with BMW, or a touchscreen, or whatever the case may be. The transport layer. The bus line itself, wiring or optical cable, in the case of auto, truck, trailer, aerospace, and marine CAN applications, is an unshielded twisted pair wire set. For automotive specialists, our diagnostic work encompasses 3 of the 4 layers: wiring, which is transport; modules, which is the physical; and software, which is the application. Okay, so I'm flipping to one more page of notes here. Sorry about that. Examples of CAN devices include the engine controller, which are also called ECM, PCM, VCM, transmission, which is TCM or ECT, ABS, lights, power windows, instrument panel, body control modules, etc. So the list goes on and on. Modern vehicle platforms now have critical autonomous modules and systems like lane departure warning systems and radar crews on board. Because of this, there are many new network topologies emerging that provide redundancy, this to prevent sudden and complete communication loss. Most cars today have upwards of 90 to 100 onboard computers. More than any, listen, this is, ready? So the 90 to 100 onboard computers. You ready for this one? More than any commercial or military airplane. Think about that for a minute. Okay? Your car, assuming you have a later model car, once again, more computers than any commercial or military airplane that has ever been built or flown. That just, for me, that kind of just blows me away. I mean, I knew it. I recently heard that, actually, that little stat, and I say recently, it was probably a year or so ago, and I've just been reminded of it, and it just, to me, that just blows me away. People don't realize the amount of technology that's in cars even today, and it's just going to get even more involved as time goes by. So anyway, that's it on this one. Just wanted to give you kind of a brief introduction and a little bit of knowledge of CAN systems and what that means and what they do and where cars are going and the reason for having to come up with CAN bus systems. It's not as simple as it used to be. So the good news is that they're, pretty reliable. Yes, it is wiring per se. Usually it's what's called twisted pair wiring, as I mentioned earlier. But it can also be part of a fiber optic system where we're talking about, light is being used to transmit digital signals or digital information around the car. So there's a lot more to it than that. There's ring bus systems, star bus systems, hybrid systems. But I'm not going to go into that. First of all, trying to talk about it, it's more of a visual thing. So, but in any case, this is some of the stuff that you're own and drive around here, folks, and just wanted to make you more aware of it. So I hope you found that a little bit informative and enlightening. Again, as usual, if you want to get a hold of me via email, it's bkpodcast5@gmail.com. And, of course, I own and operate Brad's Motorworks in Newbury Park, California, so I've got a website for that if you want to check that out. I've got a couple different web pages, so check that out if you're so inclined. And I hope you have found this enlightening. I appreciate your time, and I hope you have a great day and a fantastic tomorrow. And, let's look out for one another and help one another and ultimately love one another, okay? Even though you may not like somebody else, we can still love one another regardless of our differences. So appreciate your time. Thanks again for listening. Have a great day. Thank you for listening to this episode. It's been an honor and a privilege to spend time with you. I hope you found this of value. Please share it with family and friends. Above all else, with all you're getting, get understanding. May God bless you and keep you, and thank you again.